Chapter 13 Symmetry
Part 2.
Page 267 Exercise 13.2 1. Find the number of lines of symmetry for each of the following shapes. We have 9 different shapes here. A, B, C, D, E, F, G, H, I. 2. Copy the triangle in each of the following figures on squared paper. In each case, draw the line or lines of symmetry, if any, and identify the type of triangle. Some of you may like to trace the figures and try paper folding first. We have 4 figures A, B, C and D shown on squared paper. Page 268. 3. Complete the following table. Shape, rough figure, number of lines of symmetry. These are the 3 columns of the table. Shape, equilateral triangle, rough figure is given here. Number of lines of symmetry, 3. Square, rectangle, isosceles triangle, rhombus, circle. 4. Can you draw a triangle which has A. Exactly 1 line of symmetry, B. Exactly 2 lines of symmetry, C. Exactly 3 lines of symmetry, D. No lines of symmetry. Sketch a rough figure in each case. (5) On a squared paper, sketch the following. A. A triangle with a horizontal line of symmetry but no vertical line of symmetry. B. A quadrilateral with both horizontal and vertical lines of symmetry. C. A quadrilateral with a horizontal line of symmetry but no vertical line of symmetry. D. A hexagon with exactly 2 lines of symmetry. E. A hexagon with 6 lines of symmetry. Hint: it will be helpful if you first draw the lines of symmetry and then complete the figures. 6. Trace each figure and draw the lines of symmetry, if any. We have 6 figures given here as A, B, C, D, E, F on squared paper. Page 269. 7. Consider the letters of English alphabets A to Z. List among them the letters which have A. Vertical lines of symmetry, like A. B. Horizontal lines of symmetry, like B. C. no lines of symmetry like Q. 8. Given here are figures of a few folded sheets and designs drawn about the fold. In each case, draw a rough diagram of the complete figure that would be seen when the design is cut off. 13.5. Reflection and Symmetry. Line symmetry and mirror reflection are naturally related and linked to each other. Here is a picture showing the reflection of the English letter M. You can imagine that the mirror is invisible and can just see the letter M and its image. Page 270. The object and its image are symmetrical with reference to the mirror line. If the paper is folded, the mirror line becomes the line of symmetry. We then say that the image is the reflection of the object in the mirror line. You can also see that when an object is reflected, there is no change in the lengths and angles. That is, the lengths and angles of the object and the corresponding lengths and angles of the image are the same. However, in one aspect there is a change. That is, there is a difference between the object and the image. Can you guess what the difference is? Hint: look yourself into a mirror. Do this. On a squared sheet, draw the figure ABC and find its mirror image A-B-C- with L as the mirror line. Next to this, we have the picture of the figure ABC on a squared sheet. We also have the figure A-B-C- and L as the mirror line. Compare the lengths of AB and A-B-, BC and B-C-, AC and A-C-. Are they different? Does reflection change length of a line segment? Compare the measures of the angles. Use protractor to measure ABC and A-B-C'. Does reflection change the size of an angle? Join AA', BB' and CC'. Use your protractor to measure the angles between the lines L and AA', L and BB', L and CC'. What do you conclude about the angle between the mirror line L and the line segment joining a point and its reflected image? Try these. If you are 100 centimeters in front of a mirror, where does your image appear to be? If you move towards the mirror, how does your image move? Paper decoration. Use thin rectangular colored paper. Fold it several times and create some intricate patterns by cutting the paper like the one shown here. Identify the line symmetries in the repeating design. Use such decorative paper cutouts for festive occasions. Page 271. Kaleidoscope. A kaleidoscope uses mirrors to produce images that have several lines of symmetry. As given here, for example. Usually, two mirror strips forming a V shape are used. The angle between the mirrors determines the number of lines of symmetry. Make a kaleidoscope and try to learn more about the symmetric images produced. We have the picture of a kaleidoscope being made out of cardboard, which shows the mirror, the tape and everything. Some broken bangles are used to create patterns formed in kaleidoscope. Album. Collect symmetrical designs you come across and prepare an album. Here are a few samples. We have some figures of different objects with lines of symmetries. An application of reflectional symmetry. A paper delivery boy wants to park his cycle at some point P on the street and delivers the newspapers to houses A and B. Where should he park the cycle so that his walking distance AP plus BP will be least? Next to this, we have a figure showing this entire problem. A point P is shown in the middle, with A and B, the 2 points representing the 2 houses. You can use reflectional symmetry here. Let A' be the image of A in the mirror line, which is the street here. Then the point P is the ideal place to park the cycle, where the mirror line and A'(B) meet. Can you say why? Exercise 13.3. 1. Find the number of lines of symmetry in each of the following shapes. How will you check your answers? We have 6 different shapes given here: A, B, C, D, E, F. Page 272. Copy the following drawing on squared paper. Complete each one of them such that the resulting figure has 2 dotted lines as 2 lines of symmetry. We have 6 different figures given here on squared paper, figures A, B, C, D, E and F. How did you go about completing the picture? 3. In each figure alongside, a letter of the alphabet is shown along with a vertical line. Take the mirror image of the letter in the given line. Find which letters look the same after reflection, that is, which letters look the same in the image and which do not. Can you guess why? We have two different figures of letters A and B given here on squared paper, with lines of symmetry shown vertically. Try for O, E, M, N, P, H, L, T, S, V, X. Page 273. Rangoli patterns. Columns and rangoli are popular in our country. A few samples are given here. Note the use of symmetry in them. Collect as many patterns as possible of these and prepare an album. Try and locate symmetric portions of these patterns along with the lines of symmetry. What have we discussed? 1. A figure has line symmetry if a line can be drawn dividing the figure into two identical parts. The line is called a line of symmetry. 2. A figure may have no line of symmetry. Only one line of symmetry, two lines of symmetry, or multiple lines of symmetry. Here are some examples. Number of lines of symmetry. Example: no line of symmetry. A scalene triangle. Only one line of symmetry. An isosceles triangle. Two lines of symmetry. A rectangle. Three lines of symmetry. An equilateral triangle. 3. The line symmetry is closely related to mirror reflection. When dealing with mirror reflection, we have to take into account the left-right changes in orientation. Symmetry has plenty of applications in everyday life. As in art, architecture, textile technology, design creations, geometrical reasoning, columns, rangoli, etc.